All right, so y'all 7.5 is analyzing graphs of quadratic functions. So let me draw me a parabola. So remember, parabolas can be uphill or downhill. So what we're going to be looking at are these points that could be a minimum or maximum point on these. That, y'all, we call the vertex. So the vertex is the minimum or maximum point on the parabola. Okay. Now, some other things you notice on this vertex point of this parabola, if I drew a vertical line through it, it would split the parabola in half. So we call that the axis of symmetry. And remember, the axis of symmetry is like an imaginary line. So it's an imaginary vertical line that splits the parabola into equal halves. Okay, so the axis of symmetry comes in the form of an equation, and it'll be x equals some number. Because remember, it's going to be a vertical imaginary line there, okay? Now, also notice that these points on these parabolas, on the first parabola I got drawn, that's a minimum value. And then on the other parabola, that would be a maximum value. So it also tells us the min or the max value of the quadratic. Now, the min or max values are going to be a y value. Okay, so the line of symmetry deals with the x values of the vertex. The min or max values deal with the y values of the vertex. Now we got a formula we use to find the vertex, so we're going to use what we call the vertex formula. Now, since the vertex is a point on the parabola, the actual vertex will be finding that value. So to get the x value of the vertex, we use the formula negative b divided by 2a. So y'all, that negative b over 2a, you see that before when you was dealing with the quadratic formula, okay? Now, to get the y value, I find f of negative b over 2a. So all this means is we use negative b over 2a to find the x value. We take the x value and plug it back into the function to get the y value for it. Okay, so these will look like a pair of points. So things they'll ask me the vertex, which will be the ordered pair. They'll ask me for the line of symmetry, which will be x equals whatever the x value is. Now as for a min or max value, that'll be equal to the y value of the vertex. So really, once you've found the vertex, you got all the information you need for the other questions they're going to ask us. All right, so here we go, y'all. So start these examples. So given f of x equals x squared minus 12x plus 27, they want us to find the vertex, find the axis of symmetry, so find the axis of symmetry. Determine if there's a min or max. So determine if min or max value. And then finally they say graph the function. Alrighty, so we said the vertex formula. So let's play with this. I got an x squared minus 12x plus 27. In order to use my vertex formula, I got to find my a, b, and c on this. So remember, a, b, and c are just going to be the numbers. So since there's not a number in front of the x squared, we would treat a like a 1. B would be a negative 12. And then c would be 27. All right, so remember the vertex formula is negative b over 2a, and then f of negative b over 2a. So the first thing I'm going to find is the x value. So to get my x value, I got to find negative b over 2 times a. So write that negative, and then I'm just going to put parentheses for my variables. All right, so we got negative, b is a negative 12, so I'm going to put in that negative 12. And on bottom a was a 1. So notice what happens. You got a negative times a negative. That's going to make that a positive 12 on top. 2 times 1 gives me a 2 on the bottom. So that my x value, 12 divided by 2, would be 6. So I know this part is going to be a 6. So then it wants me to find the y value of my vertex. In the y value, it says take the function and put in whatever you got with the negative b over 2a. So my negative b over 2a was a 6. So I need to find f of 6. So f of 6 means we're going to take this function, and where they got an x, I'm going to put a 6. So I got 6 squared, which is x squared, minus 12 times 6 plus 27. All right, y'all, let's see what we get. 6 times 6 is 36, minus 12 times 6 is what, 72, and then plus my 27. All right, y'all, let's see what we get here. 36 minus 72 is going to be a negative 36, plus 27 is going to give me a negative 9. So my vertex will be 6 for the x value, negative 9 for the y value. So we'll put vertex under that. So now that I know that vertex, I can find my axis of symmetry. So the axis of symmetry would be x equals, and the x value was a 6. So now we got to figure out, do we have a minimum or a maximum? And to tell that, I look at the very first term on here, the x squared term. If the x squared term is positive, you got a minimum. If the x squared term is negative, you got a maximum. So since this x squared term is positive, we're going to have a minimum. And I'll put the reason is because the x squared term is positive. Okay? And then y'all, actually, if you wanted to, go over here to y equals. Let me clear everything on mine. And I can put this in here. X squared minus 12x plus 27. And if you hit graph, you'll see that it's definitely got a minimum, which is what we said. And it looks like we said a minimum of -9. And if you look at that, it's going to drop down to about -9 on that y-axis, okay? And it happens that the x value over here at 6. See, if you took the 6 and went straight down, you would hit that point right there, okay? But yeah, just drawing them will sort of help you see whether you got that min or max on it, okay? All right, so I'm going to graph this now. So I'm going to graph it by hand. So I had what? F of x equaled x squared minus 12x plus 27. All right, so I'm trying to go at about 10 on this because I know I had that -9 value. All right, so to graph this, I knew my vertex was what? 6 and a -9. So the very first point I'm going to plot would be that 6, -9. So we got to go right 6, woo, and then down 9. Well, I'm happy because I remember on my graph it was over there in that area. Y'all, here's the trick. Now, I need to find some more points on this because I've only got 1 point, and I need at least 3 points to graph these parabolas. So what I would do maybe to get my other 2 points is solve this equation and find the zeros where it's crossing over that x-axis. So one quick way would be to use that quadratic formula program I gave you. So I'm going to go to my quad and then run that. So A would be a 1, B would be the -12, C would be 27, and when I hit enter, it'll give me my x-intercepts, which are 9 and 3. That means it's crossing this x-axis at the 3 and at the 9 here. And y'all, once you do that, it would let you draw your parabola right up through there, okay? And then if we look at our graph, pretty close, okay? So use your vertex for 1 point and then just solve that to get 2 more points. Or you can graph it on the calculator and go to your table. And notice when I get over here in my positive values, there's my low point at -9, and then you can start seeing the symmetry around it. -8 on either side. I think that's -5s and so on, okay? So take the vertex and then solve that. That'll give you some points and then graph it. So they're not too bad. It's not as bad as y'all had to when y'all were switching them graphs around and stuff, okay? All right, let's see. All right, y'all, same thing on this one. They're giving us f of x equals 2x squared plus 14x plus 27. So I'm going to find the vertex, axis of symmetry, and then the min and max value again. So to get that vertex, I'm going to find the x value first. So once again, the x value is -b divided by 2a. So let me get that ready. -b divided by 2 times a. All right, this time b is a positive 14 I'm putting in. A is a positive 2. Oh, y'all, look what happens. I get a -14 on top. 2 times 2 is 4 on the bottom. -14 will not divide by the 4, but I can simplify this down. Let's see, both of them divide by what, a 2? So that's going to give me a -7 over 2. So our vertex has a fractional x value. So to get the y value, I'm going to find f of a -7/2. So y'all, we're about to have fun with this one, right? Because here's my 2. In place of the x, I got -7/2 squared plus 14 times a -7/2 plus 27. Y'all, I'm going to do one step at a time on this. The first thing you got to do on that is that exponent. Exponents have priority over everything else other than parentheses. So bring this 2 down. -7/2 squared. Now you can do that on the calculator. Put that in parentheses, -7 divided by 2 in parentheses and square it. Remember, I don't want a decimal, so I hit math and enter twice, and it gives me a 49 over 4. So all they did, they squared the top. -7 times -7 is a 49. On the bottom, you square that also. 2 times 2 is 4. Now I just want to write down everything else. So let's see, we got multiplication, multiplication, and then everything else is being added. So I'm going to do both of my multiplications next. Now, when you multiply, if you want to, you can make the numbers look like fractions. And remember, you multiply straight across. So let's see, 2 times 49 is 98 over 4. So I get a 98 over 4. So I just went straight across. Now, I'm not reducing these yet until I see what I get on everything. So let's see what we got here. A positive times a negative is going to make that part negative. All right, y'all, 14 times 7 on top is 98. Over 1 times 2 on the bottom is 2. And then bring down your 27 at the end. And at this point, since they got fractions, I would put a 1 under the 27. Alrighty, so now In order to add these fractions, they need a common denominator, right? So, what's what I want to do? I can simplify this 98 over 4. Remember, I want a fraction. So that should turn into a 49 halves minus a 98 halves. Now, I need this to have a 2 on the bottom. So since I want a 2 on the bottom, I'm going to multiply 1 times 2. That means the top, I got to multiply by the 2 also. So that this gives me a 54 over 2. Now, y'all remember, I'm doing this by hand. Y'all could have come up to this part right here and done this whole thing on the calculator and got what I'm about to get, okay? All right, so since everything's got a 2 on the bottom, after I do all this, I'm still going to have a 2 on the bottom. So I need to figure out what 49 minus 98 is going to give me a negative 49 over 2 plus my 54 over 2. So that's going to give what? 54 minus 49 gives me a 5 over 2. Final answer. So y'all watch this. Let me show you this part right here. I could have did 2 and in parentheses negative 7 divided by 2, close parentheses, and squared that. Then I had plus 14 times negative 7 divided by 2. Then I had a plus 27. So when I hit enter, remember it's going to give me a decimal, so I just hit math and enter twice, and it gives me the 5 halves. So hand way or calculator, either way. So that my x value was the negative 7 halves, the y value was a positive 5 halves. All right, so now I can find the axis of symmetry. Because y'all, we've done the work now, so we know the axis of symmetry is always x equals the x value, which is a negative 7 halves. Then I got to figure out, do I have a min or a maximum? So way up here on my equation, I had a positive 2x squared. Since that's a positive 2x squared, I have a minimum. And the minimum is a minimum value of the 5 halves. So remember, your y value is the min or max value. The x value gives you that line of symmetry, okay? All right, so I'm not going to graph it. I'll show y'all some of the graphing on those when we go to the support. So let me move on. All right, y'all, this one has a negative x squared minus 10x minus 28. So remember, for the vertex, you would come in and find your numbers. Now, y'all, let me show you some. I sent out some programs the other day that had one on there for vertex, I think. So if you go down to there, you will find a vertex formula. You just hit enter, and then you put in the numbers. So my A here would be a negative 1. My B would be a negative 10. And my C would be a negative 28. So when you put them in, you should get a negative 5, negative 3. So let's see if that's what we get on this, okay? So A was negative 1, B was negative 10, C was negative 28. So I'm going to get my x value first, negative B over 2A. 2 . So y'all, B is a negative 10. So that double negative will make that 10 positive on top. And then my A was a negative 1. So y'all watch this. I got 3 negatives, which means this thing will stay negative. Because the top becomes a positive 10, but the bottom stays a negative 2. So that's why this had a overall value of being a negative, okay? And then negative 10 divided by 2 gives me a negative 5. All right, there's what the calculator said for that, negative 5. Now remember, to get the y value, I find f of a negative 5. So you bring down that negative, x squared minus 10 times x minus 28. So let's put in the negative 5 for the x's now. And y'all, at that point, calculator will knock that out, okay? So once again, I'm going to go by hand. So this negative is in front of the parentheses, so you bring it down. Negative 5 times negative 5 is 25. So notice that's going to stay negative. The biggest mistake people do to this is they go, oh, negative times a negative is a positive. Then they square the 5 and get a positive 25 instead of a negative 25. Exponent goes before that multiplying, okay? All right, then down here, you're subtracting 10 times a negative 5, which means you're going to be adding 10 times 5, which is 50. And then at the end is a minus 28. All right, so let's see what I get. Negative 25 and 50 is a positive 25. 25 minus 28 is a negative 3, which is just exactly what that calculator gave us. So our vertex is negative 5, negative 3. So that means our axis of symmetry is going to be x equals the x value, which is a negative 5. Oh, and then what else? I got to find a minimum or a maximum. So this one has a negative x squared. If you graph that, a negative x squared, the parabola will be upside down, which means we have a max, and the max value is going to be the y value, which is a negative 3. And then graphing it, I would graph that point there, and then probably hit it with the quad to get me 2 x-intercepts, okay? Alrighty, so now we're going to play with a few true or false questions. Seeing what y'all got from these last few sections here, okay? So this one says the function f of x equals negative 9x squared plus 9x minus 7 has a, oh, where'd it go? Maximum value. So the function negative 9x squared plus a 9x minus 7 has a maximum value.
Yeah.
So if nothing else, you could graph that. But remember, since that's a negative, you did good, because remember that negative flips it over, and it does have a maximum, so that is definitely true. Good job. And that's all I'm looking at is that first term. Was it negative or positive, right? Okay, true or false. The graph h of x equals x plus 4 squared can be obtained from the graph h of x equals x squared left 4 units. So the graph of x plus 4 squared can be obtained from the graph of x squared if you move it left 4 units. Is that true or false? And if you remember, they're looking at your transformations. In any time you're inside the parentheses with the x, it moves opposite what you think. So since that's a plus 4, it's actually going to move me left 4, which makes this one true again. All right, so last one, let's see, true or false. And then we'll break out the big boy problems, okay? All right, so the axis of symmetry of the function f of x equals 2 times x plus 4 squared plus 7 is going to be at x equals -4. And what you got to think on this one is again, that right there. Since that's a positive 4, it's actually going to move my graph left 4 units, which would definitely be on that -4. And since that's the x value, that would be the axis of symmetry. So once again, we're going to put true for that. All right, y'all, here comes the big problems. So they're going to be given f of x equals x squared plus 10x plus 24. Ooh, we got to find a lot. We got to find the vertex, min or max, and the value. So we got to determine if it's a min or max and tell them that value. Find the range. Some of y'all didn't like my range on the last one. And then intervals of increasing and decreasing. So intervals of increasing and decreasing. So if you notice, they got a lot of stuff they want me to do on this. So the first thing is that vertex. So I'm going to work on my vertex first. So remember, on the vertex, I got to get my x value, then my y value. So the x is still going to be -b over 2a. So -b over 2 times a. So b is a +10, so I'm going to put that +10 in. A would be a +1. So notice I get a -10 over 2, which will give us a -5. So we know half of our vertex will be -5. Now we got to get the y value. So the y value will be f of a -5. So that's going to be -5 squared plus 10 times negative 5 plus 24. All right, so negative 5 squared is a positive 25. 10 times negative 5 is a negative 50. And then I get a positive 24 at the end. If you've ever noticed when you're doing this, when you're finding that y value, that second number is always twice as big as that first number. While ago I had a 49 and a 98. Now I got a 25 and a 50. You'll see these little patterns on these, okay? All right, 25 minus 50 is a negative 25. Negative 25 plus 24 is a negative 1. So my y value is negative 1. So for the vertex, they want that point, negative 5, negative 1. Now we got to figure out min or max. Since that's a positive 1 in front of that x squared, that's positive, which means my graph is going to be downward, which means I got a minimum of negative 1. That means negative 1 is the smallest y value you'll find on that parabola, okay? The range, so the range, since you got a minimum, you're going to start with that minimum value. If you had a maximum, you would end with the maximum value. So the range starts at the smallest y value of negative 1, and I'm using square brackets because it can equal that negative 1. So notice, here's your negative 1. Now you're going up into y directions. You're headed towards what we call positive infinity. And y'all, infinity always has a curve around it. So since the range can equal negative 1, we had to use the bracket, okay? So now they want intervals of increasing and decreasing. So I'll do the increasing first. So now you got to look at x values. So on your graph, here's your negative 5, right? That's where this happened at. So on each side of negative 5, your graph is going to come up and down. So the increasing will start at that negative 5. So it's going to start at negative 5. And you got to think x's. As your x's get bigger, your graph is increasing. So this is headed towards infinity on the x's. Now y'all, decreasing will be a little different. It's decreasing. It starts out here on these x's out here somewhere. So we're going to say this one starts at negative infinity. And this graph is decreasing as I go down my x's and I hit negative 5. So that line of symmetry is going to be the changing point from the decreasing turning into the increasing, okay? And then let's see, that was it on that, okay? So we had a vertex. Then we said we had a minimum value because the vertex was positive, the x value. Gave it that value of negative 1. And then we had to find the range, which was the y values. So remember, the range deals with y values. The increasing and decreasing deals with the x values. Okay? All right, so that is about the same. So one more problem, and then I'll do the 6-1. This is an application of the vertex formula. So a toy rocket is shot vertically into the air from a launching pad. So shot in the air from a launching pad that is 6 feet above the ground with an initial velocity of 112 feet per second. So they're telling me the height, h, can be found by the formula, which is h of t equals negative 16t squared plus 112t plus 6. So they want to know how long till it reaches maximum height, and then how high, or yeah, how high is the maximum. So I got to find how long it takes my rocket to hit that maximum height, and then tell them the maximum height. So let me show you what this, they told me the height h, which this is what the formula is for, the height, and the height depends on the time. How long it's been in the air will tell me how high it gets, okay? So let me explain the formula here. You see it said it starts with a 6 feet above the ground. Well, that's what this 6 is. If this was 0 for the time, your height would be the 6 feet that it is on the pad, okay? Now the 112t is the velocity or the speed. Velocity is just speed with direction. So that's where they got the 112. So it's going to go ever how fast the time is, multiplied by 112, and that's going to give you the height. But then I got this fella in here. They didn't tell us nothing about this negative 16 t squared, but y'all, negative t squared, the negative 16 t squared is the effects of the gravity. Gravity is going to be trying to pull that thing down, okay? So that's what the negative 16 t squared is. So to find the maximum height, we're looking for that point where the rocket's at its highest. We're going to use the vertex formula. So for me, A would be negative 16, B would be 112, and C would be 6. So here's the thing. Since T is the variable for time, when I'm done, T will be like my X, and then the height will be the Y value, okay? So remember, since they got a T here instead of an X, time is now the variable, okay? So we want the X coordinate of the vertex, which will be negative B over 2A. So that'll be negative 112 over 2 times that negative 16. So we do see that the negatives are all going to cancel. So I need to figure out what 112 divided by 32 will give me. So that's going to give me 3.5. Okay, now this will actually take this decimals on this. Yeah, it'll actually take the decimals on that, which means 3.5 seconds is all it took for my little rocket to reach its maximum height. So now I'm going to find what that height is, which means I'm going to find F of the 3.5. So take my equation, negative 16, T, which is 3.5 squared, plus 112, T, which is 3.5, plus 6. All right, so the first thing I'll do, if I was doing it by hand, would square to 3.5. So let's see, 3.5 squared is going to give me 12.25 plus 112 times 3.5 plus 6. So all I did was work my exponent on that step. Now I'm going to do all the multiplying. So 12.25 times negative 16 gives me a negative 196. 112 times 3.5 will give me 392. And then at the end is my plus 6. And y'all, that 392 is still double that negative 196, okay? All right, so let's see what we get. 392 minus 196 is going to give you positive 196 plus 6 gives me a 202. So it took 3.5 seconds for the rocket to reach maximum height of 202 feet. So that's what's nice about your vertex formula. You can shoot rockets and see how long it takes them to reach these maximum heights. Okay. We used to have a rocket day at school, but coronavirus sort of took care of that. Maybe next year we'll have a rocket day. Alrighty, so that was what, 7.5? So I'm about to give y'all a 10-minute break, and then we'll do the 6.1, and 6.1 ain't that long, really. I think there's like 6 problems in it, so we'll knock it out pretty quick. So let me pause this. It's not very long. It'll be an easy section.
I hope so.
We just
says you because you're the teacher.
All right, 6.1 is radical expressions. So there's one problem where we find the domain, and then the rest of them are just showing you how to graph on that calculator, okay? So to find the domain, of a radical expression, first thing we'll do, set the radicand. So the radicand is the stuff under the radical. So we're going to set the radicand greater than or equal to 0. So especially y'all that just come out of foundations, I think y'all messed with radicals in there. We got to keep it positive or 0 under the radical, because if we get negative numbers and you try to take square roots, that's where those imaginary numbers came from, okay? So I'm going to set that radicand greater than or equal to 0, and then write in interval notation. Okay, so here we go. We're going to determine the domain. You know, these are the radicals. They were the second thing I said you were worried about on a domain. The first was the fractions, and then the second thing is the radicals. And those are the only 2 things we're going to worry about on our domains, okay? So this is f of x equals a square root of 4x plus 3. All right, so it said we got to take what's under the radical, the 4x plus 3, and we got to set it greater than or equal to 0. All right, so I'm going to solve that and then see what I get. Oh, now here, where I wrote right in interval notation, that could be or set builder. My bad. Notation. This book writes them in both ways, so we'll do them both ways. Now, to solve this, I'm going to get this x by itself and everything on the other side. So the first thing I would do is subtract 3. So the 4x has to be greater than or equal to a negative 3. And then divide both sides by 4. So that my x is greater than or equal to a negative 3/4. So if you put a 3/4 into this, you'll get a 0, which is good. But any number less than that negative 3/4 would make this stay negative, which means it's imaginary. So we got to be greater than or equal to a negative 3/4. So set builder notation, you'll have x such that x is greater than or equal to negative 3/4. So in set builder, you just put the answer in there and be done with it, okay? Interval notation, since the negative 3/4 is the smallest number, you're going to have the negative 3/4 with a bracket by it. Radicals get brackets. The fractions got curvy parentheses. Now, greater than, if negative 3/4 is the smallest number, it heads towards the right as far as it can go. It's headed towards infinity. Now, the way they do them on the homework is a set builder. I always like to do these so that y'all can keep them to where you can do them also, okay? All right, and the rest of these are graphing. So graphing radical expressions. All right, so I'm just going to draw me a little table real quick. I mean a little graph. So I'll go at about 10 on this. All right, so I'm just going to make a little table down here so that I can get some values. So this will show you what the basic graph of the radicals is going to be, okay? Now, x can't be a negative number because I'm plotting this. F of x equals the square root of x. So let's see. If x is a 0, I put a 0 in. Square root of 0 is 0. Now, y'all watch this. I can't put in a negative x because if I try to take the square root of a negative 1, it tells me, hey, you got a non-real answer, which means it's pretty much what? Imaginary. Okay? So the next number I'm going to put in is a 1. You put in a 1, square root of 1 is 1. Now, I'm not going to put a 2 in there because I can't take the square root of a 2. I'm not going to put a 3 here because I can't take the square root of a 3. But I'm going to put a 4 here because if I put a 4 in there, the square root of 4 would give me a 2. Now, 2 and 3 do have x values, but y'all, watch this. If I take the square root of 2, I get 1.41. So I don't want to have to try to plot decimals. So I try to find numbers that have square roots on them, okay? So here we go, 0, 0, and then over 1 and up 1, and then I was at 2, 4. My next number that has a square root would be a 9. And the square root of 9 would be 3. So over here at 9, oh, hang on, I think I did something wrong. That point ain't there, y'all. I was at 4, 2, which would be right there. Ooh, how'd I get backwards? I did 2, 4. I didn't hear no one say, whoa, what's up? All right, this point was 9, 3, so 9 up to 3. So if you notice, it makes a little curve that goes off to the right. That would be the basic graph. So what's going to happen, we're going to graph some of those that get moved around just a little bit. So we're going to graph first f of x equals 3 to the square root of x. Now, y'all, watch this. On the homework, they're going to give you problems like this. All we're going to do is pick the picture that does. So go to your y equals, clear that, put in 3. To get the radical, you hit second x squared. That brings up a radical. And inside the radical, you put a x. Now, we hit graph. Now, there's 3 possible graphs that go to the right like that. So do you see how theirs is going from -5 to 15 on the y's and then -10 to 10 on the x's? Watch this. I hit the window button here. My x's are good, -10 to 10, but my y minimum is only -5, so I'm going to change that to a -5. And then the y max is a 15. By doing that, when I hit graph, I should get exactly one of these pictures. So y'all, to me, that looks like the B, don't it? Got a little bit of that uphill to it, like that B does. A is a little flatter, and then D is way flat, okay? So if you put the window like they got it, you'll pick them out perfectly, okay? That next one has a -5 in front. A negative flips the graph over, remember? So instead of it going uphill, it's going to go downhill left to right. And y'all, I only see one that's going downhill, but here we go. I'm going to put this in as a -5, second x squared to get the radical, and then under it was a x. Now remember, when I graph it, it's not going to look like theirs because their y values are different. So let me go to my window. The x's are going -10 to 10, so I'm good on them. It looks like the y's on here, well, this one, I don't know why they messed it up, but they go from -14 to a +6 up here. Now, this one's backwards, so I don't know what they're doing on that one there. But y'all, the only choice I can pick would be the B. All right, then here we go. Y equals. So all I got to do, it looks like, is delete that negative, because that's the 5 square root of x. So their window is going -10 to 10, but the y values are going from -5 to 15. So let me go to -5 to 15. That way I can guarantee I get one of these pictures, hit graph. And y'all, once again, it looks like the lucky number for me is going to be B every time, right? Alrighty, so what's going to happen when I subtract 9 from this graph? Since it's under the radical, I'm attacking the x, and anytime you subtract from the x in parentheses, you're going to move it right. So let's see, that looks like they moved it down. This one looks like they moved it right, so that'd be my guess. You know, this one they moved left and somehow flipped it. And then D looks like it moved left. So let's go to y equals. Clear that. So now, since everything's under the radical, you would hit the radical first, second x squared, and then put in x minus 9. Now, if you notice these windows, everything's going from negative 20 to 20. So let me change everything from negative 20 to 20, and then negative 20 to 20. So now I can guarantee one of these 4 pictures. I hit graph. And y'all, once, oh my God, everything is ending up B for me. All right, this one goes back to a 10 by 10. So if you want to get to a 10 by 10 quickly, you can hit zoom and number 6, and it puts it right back on a 10 by 10, okay? So now let me get this. I'm going to clear that. Everything's under the radical, so hit second x squared to get your radical. And then that's a 4 plus 4x. All right, I fixed it to a 10 by 10 by hitting zoom standard. So now I hit graph, and I should get one of my pictures. Now, yeah, this time I knew it wasn't going to be B this time because that was a straight line. There's no way these can be straight lines. There's no way we can reverse the direction of them. So, y'all, the only possible choice was going to be our D on that, okay? All right, let's see. This one I'm going to change the window a little bit when I graph it. So let me clear that. Everything's under the radical, so hit the radical first, second x squared. That is a 2x minus 7. So notice this time the window, the x's are good. It's the y's I got to change from a -5 to a +5. All right, so my window's the same, so let's see when we hit enter. The only one it could be would be back to B again. So since that 7 was negative, it actually moved it to the right on that, okay? So there's no way a radical is going to get a straight line, so those are automatically thrown out, okay? There's no way we can reverse the direction of it yet. I can reflect it over to X, but I ain't learned how to reflect it over to Y yet, okay? Alrighty, so that looks like it. So what we'll do now is some support. So I'm going to stop this share. And then I'll actually stop this video.